Alright, this video covers support 6B for your variation and whisker plots preparation. So we're going to share our screen and go to the problems here. So question 1 in here wants me to evaluate the square root. Evaluate the square root. And they're giving me a square root of 16. So remember, the square root finds what number times itself equals 16. So the number that you multiply times itself to equal 16 would be 4. So the square root of 16 would be 4. Now on the calculator, you can do square roots. So let me turn mine on. I'm going to clear my screen. So to do a square root, right here above the x squared key, where I got my pen, you see a blue radical. That's the square root. So what that means is anything that's blue and you want to use it, you hit the second button first, and then you hit the button with the item you want. So I wanted the square root, so I hit second x squared. So that gave me the square root. Then I put my 16 into it and hit enter. And notice it also gave me 4. So either way, and if you want to check yourself, 4 times 4 is 16. Okay, so for this problem, they want me to find mean and median for the waiting times at the big bank, and they're going to give me the times. So they want me to show my work clearly and verify that both are the same. So big bank waiting times are 4.1, 5.2, 5.6, 6.2, 6.7, 7.2, 7.7, 7.7, 8.5, 9.3, and 11.0. So first, we're going to tell how to find our mean. And if you remember, I gave you a formula that said the mean equaled the sum of all data divided by the number of data, how many I had. Okay, so to do that for that problem, I'm going to add 4.1 plus 5.2 plus 5.6 plus 6.2 plus 6.7 plus 7.2 plus 7.7 plus 7.7 plus 8.5 plus 9.3 plus 11.0. I'm going to add all them up and then divide by how many numbers I had. So I had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers. All right, so on the calculator, I'm going to add all them together real quick and see what that equals. So 4.1 plus 5.2 plus 5.6 plus 6.2 plus 6.7 plus 7.2 plus 7.7 plus 7.7 plus 8.5 plus 9.3 plus 11.0. All them together equaled 79.2. I'm going to take that number and divide by that 11 and see what I get. So if I divide that by 11, my mean or my average is 7.2. So now they want me to find my median. So I know I had 11 data units. So if I got 11 data units, that's an odd number. So I'm looking for the exact middle number. So since I got 11 of these, I'm going to have 5 on each side. So watch this. 1, 2, 3, 4, 5. So the sixth number is 7.2. And then on the right side of it, I got 1, 2, 3, 4, 5. So I got 5 numbers, both sides. So the middle number is going to be 7.2. Okay. All right. And the way I found that was the sixth number. So in the homework, they'll ask you the median is the blank value in the sorted data. It'll be the sixth value since it was an odd one and you had 5 on both sides. And its value was the 7.2. Okay. And if you notice, they'll ask you, are they greater than, less than, or equal? Well, look here. My mean was 7.2. My median was 7.2. So my mean is going to equal my median for that problem. So that means it's a pretty good indicator of that data because remember when the mean and the median are equal, my curve is a nice little curve where it's symmetric on both sides when those are equal, okay? All right, for number 3, they want me to find the standard deviation. So this is a little trickier, and I'm going to round it one more decimal place than the data. So my data looks like it's going to be rounded as integers. So I got a 19, a 14, a 13, a 20, a 15, a 10, a 19, a 6, and a 6. So to find the standard deviation, you're going to take all these numbers, and since I don't really have to find the median on this, they just want me to find standard deviation, I don't have to worry about ordering them, okay? So let me pull my camera down a little bit. So I'm just going to line my numbers up there. These are going to be my X's. 19, 14, 13, 20, 15, 10, 19, 6, and 6. Okay? So I'm going to draw me a little box here because those are my X's. Then I'm going to take each X and subtract my mean and put those answers in this column. Once I do that, I'm going to see what X each bar minus my mean is when I square it. So I'll square each of these answers. Down here, I'm going to find the sum of all these X minus means. I'll add this row up, okay? Because the formula for the standard deviation, I'm going to abbreviate standard deviation. Its formula is the square root of the sum of the X minus the means squared. Oh, I need a square on that, okay? Because we're going to add up all these squares and get a big number here. All righty. Now, we divide all this by n minus 1. N is the number of data points we got. So for us, we got 1, 2, 3, 4, 5, 6, 7, 8, 9. We got 9 data points, so n will be 9. So that'll be 9 minus 1, which will be an 8 on the bottom eventually, okay? So first of all, we got to find our mean. So remember, to find the mean, our mean is going to equal all these numbers added together, 19 plus 14 plus 13 plus 20 plus my 15 plus my 10 plus my 19, my 6, and my 6. So when I add all my data points up, I get 122. And remember, I need to divide that by 1, 2, 3, 4, 5, 6, 7, 8, 9. I had 9 data points. So divide 122 by 9. And our mean is going to be 13.57. I'm just going to go 2 digits because none of these had decimals. So I'll just use 2 decimals until I get to the end, okay? So let's see what they're saying. So they said round one more data place than the original data. So I'm going to make that a 13.6 for my mean. So this second row says x minus mean. So we take each of these x's, 19, and we're going to subtract our mean, which is 13.6. So that's going to give me 5.4 for this row. Now, if I square the 5.4, so square that, that's going to equal 29.16. Okay, so now I'll take the next one, 14 minus my mean, which is 13.6. That's going to equal 0.4. If I square the 0.4, I get 0.16. All right, same thing here. I do 13 minus 13.6. I get a negative 0.6. But when you square a negative 0.6, you get a 0.36. So see how squaring them turns all these numbers into positive numbers? So that's why we square them. All right, so I'll do the same thing. 20 minus 13.6 is going to equal 6.4. Square that, we get 40.96. All right, 15 minus 13.6 is going to equal 1.4. Square that, you get 1.96. All right, next we got 10 minus 13.6. That's a negative 3.6. We square that, we get 12.96. All right, 19 minus 13.6 is a 5.4. Square that, we get 29.16. See, all these are how far is our x's from our mean? How much are they varying from that mean? So notice some are a little further than others. And now what we're doing, we're squaring them to make them positive. But if you notice my last step, I'm going to take the square root. So that's going to undo all that squaring that we're doing, okay? So let's finish this off. 6 minus 13.6 is going to equal negative 7.6. Square that, I get 57.76. So this is the same number, so I'll have the same values, 57.76. Now, I'm going to add this whole row up, and that'll be the sum. That's what that E means, is sum. This will be the sum of all my x minus means in squaring them, okay? So we'll do 29.16 plus 0.16 plus 0.36 plus 40.96 plus 1.96 plus 12.96 plus what? 29.16 plus 57.76 plus 57.76. So I just added this whole row up, and that's going to equal 230.24. So I'm going to keep it out 2 decimals, what they're giving me. So my standard deviation, it says, is going to equal the sum of the x minus mean squared. Well, we just found that. That was 230.24. Divided by n minus 1. Well, n is 9, so 9 minus 1 is 8. So let's see what we're going to get. So I'm going to take the 230.24, divide by the 8. That's going to equal 28.78. And then my last step, I'm going to take the square root of 28.78. So you figure out what this number equals, and then you take the square root of that number, and that's going to give me a 5 point. So they said go one more decimal than this data had. So since this didn't have no decimal points on any of the numbers, I only need to go one decimal point. So I need to round that 3 to a 4. So the standard deviation is 5.4. So that means on either side of our median that most of our data is within negative 5.4 or positive 5.4 from our mean or our median or our average, okay? So that means a lot of our data is really tight together, and we could say overall 68%, I believe, percent of our data is within this one standard deviation, okay? So that's all this means. It just tells us on average how far is our data off from that mean. It could be a positive 5/4 or a negative 5/4 if you're going in the other direction. So I had one more of these problems I wanted to do, and they want me to find the same thing. So they want me to find the standard deviation. So this will give you, whoops, let me pull that up. This will give you a second version of this problem I'm about to do. My data is 16.3, 17, 32.6, 35.7, 22.6, and then 20.7. All right, I'm going to round my answer one decimal place in the original data. So since this has one decimal place in some of this, I'm going to round it 2 decimal places. All right, so first I'm going to figure out all my x's and then my x minus my mean. Then I'll figure out my x minus my mean squared is. Then we'll add all them together. And once again, we know our formula for our standard deviation equals the square root of the sum of our x minus means squared over our n minus 1. So n is 1, 2, 3, 4, 5, 6. N is going to equal 6 for us for this problem because I got 6 points. All right, so let me put my x's. 16.3, 17, 32.6, 35.7, 22.6, 20.7. So remember, I got to find my mean. So my mean is going to equal all these added together divided by 6 because that's how many I got. So 16.3 plus 17 plus 32.6 plus 35.7 plus 22.6 plus 20.7 equals 144.9 divided by 6, which gives me a mean of 24.15. So that's my average. I added them all together, added them, and subtracted 6. So remember down here, when I get these x minus mean square, I'm going to add all them together and see what all these squares equal. That's what that big E, that's epsilon, and that means the sum of all these that we're adding, okay? So let's start taking our 16.3 minus 24.15. So notice we always subtract, and then 17 minus 24.15 is negative 7.15. 32.6 minus 24.15 is 8.45. So I should be squaring these, but I'll do that on the next step. 35.7 minus 24.15 is going to equal 11.55. 22.6 minus 24.15 equals negative 1.55. 20.7 minus 24.15 equals negative 3.45. Now I got to go back and square all these. So negative 7.85 squared equals 61.6225. Now I didn't put I should have put that in parentheses. I should have did parentheses, negative 7.15, and then squared it so that it would have squared my negative. So 51.1225, 8.45, square that, you get 71.4025. All these are going to be positive numbers because a negative times a negative is a positive, okay? So I'm mainly just wanting to see what these numbers equal when I square them. So that's 133.4025. That'll be 1.55 squared. Remember, sign don't matter because a negative times a negative is going to be a positive anyway. So that's 2.4025. And then 3.45, square that. You get 11.9025. So now we're going to add all them together to get the sum. So 61.6225 plus 51.1225 plus 71.4025 plus 133.4025 plus 2.4025 plus 11.9025. All those added together equals 331.855. So now that's going to be the top part of my equation. So this is going to equal, my standard deviation is going to equal this sum, which was 331.855, divided by my n, which is 6, minus 1. 6 minus 1 is 5. So remember, first I want to take that 331.855 divided by 5, and that gives me a square root I'm about to take of a 66.371. So let's see what the square root, second x squared to get the radical, 66.371 goes underneath it. So when I hit enter, I get 8 point. So let's see, they wanted me to go one more decimal than my data. So I have one decimal place in some of these. So I need to go 2 decimal places. So that'll be where the 4 is. So since there's a 6 behind the 4, that's going to become an 8.15. So that means if my median was 24 here in the middle of my curve, then on each side, if you add 8.15 or subtract 8.15, that means that at least 2/3 of the data points are within one standard deviation on either side, okay? So we'll play more with graphs so that you can understand them. And we'll learn that one standard deviation usually has like 68% of the data. If I went out another plus another 8.15 or minus another 0.815, this would be 2 standard deviations, and 95% of your data or so is within those 2 standard deviations. Anything else outside here is almost like an outlier. It very seldom happens, okay? So like 5% of it has a chance of being outside that data. All righty, y'all. So I believe that takes care of the support lesson for, what was I doing? 6. Yeah, this was 6B, getting you ready for those standard deviation problems we're about to do in MR part of it. And we'll even do what we call a box and whisker part box plot. So it looks like a little box with little ends coming off. And we'll learn about first quartile, medians, and second quartiles all again in the main course. So I'm going to stop this share, and I'll see y'all for the main course. Good luck.